Next, we are seeing special curvilinear coordinate systems. Already I mentioned a few times the curvilinear coordinate system is the more general system, right? All other coordinate systems which we use, they are the special cases of that, right? So special curvilinear coordinate systems, it includes all other systems which we deal with. The first one is the rectangular coordinate system. Rectangular coordinate system is nothing new. This is what we call as the Cartesian system, or in simple terms, whatever coordinate system we use in general, that is the rectangular coordinate system. So as per the rectangular coordinate system, any point in space, see, any coordinate system, it is used to describe a point in space, right? So now our point is P. To describe this point, where in space it exactly occurs, to exactly locate it only we need all the coordinate systems. So in this rectangular coordinate systems, we use this x, y, z as the frames of references. X, y, x, these are our references. So in place of u, v, w, we use x, y, z. In curvilinear coordinate system, generalized terms are u, v, w. In this rectangular systems, x, y, z. And what are these x? And you know, if this is the point, we consider the frames of references as x, y, z, the three vertical lines, and I, j, k as our vectors, unit vectors, right? And when we join this P to the origin, it is going to be the position vector R, which is a line. In rectangular coordinate system, when you join 2 points, it is going to be a line. So this is a line which is R vector. OP vector is R vector, the position vector. And you know how to define it, how many units it can travel. So you will take the projection of this P on XY, and when you draw the lines, expand these lines, you know, you will get how much distance you can travel, how many units you have to travel in x-axis, and how many units you need to travel along y-axis, how many units you need to travel along z-axis. That decides the vector xi plus yj plus zk. So the points are x, y, z. So for rectangular systems, u is x, v is y, w is z, and all the unit vectors e1, e2, e3 are respectively I, j, k. This is our generalized system. Already in our previous slides in curvilinear systems, we know for a general system, ds square must be equal to ds1 square plus ds2 square plus ds3 square. In our case, what is this s? S is nothing but this position vector. So in such case, ds square becomes dr square. For this rectangular coordinate system, ds square becomes dr square, and subsequently you know what is dr. dr is xi plus yj plus zk, a vector. When you take the dot product of this vector dr dot dr, you get dr square. So you get dx square plus dy square plus dz square by definition. So for rectangular system, dr square is this. Always to find the metric parameter, and you know the method, we write the description of ds square in terms of metric parameters, and we will equate with the available expression for that system. So this expression, you know, for curvilinear system in terms of metric parameter, ds square can be written as h1 square du square plus h2 square dv square plus h3 square dw square. For our system, u is x, v is y, w is z. So here it becomes h1 square dx square plus h2 square dy square plus h3 square dz square, right? So now you have that expression. When you equate these two expressions, this and this, if you equate, h1 square must be equal to 1. h2 square must be equal to 1. h3 square must be equal to 1. So all of them are 1. So h1, h2, h3 are equal to 1. This you know, for rectangular coordinate system, the metric parameters are 1. All are distances, x, y, z, all have same dimension. So h1, h2, h3 must be equal to 1. Similarly, we can find the metric parameters for other special coordinate systems also. Procedure is the same. You find dx square, dy square, dz square for every system. Then finally equate with this expression for ds square. You will get h1, h2, h3 square values first, and you can find their values. This is the idea. Can you move?
Yes, ma'am.
Yes, ma'am.
Okay. So now we know the idea about the values of metric parameters. So from this, let's find a gradient. We know the expression for gradient from the general system, curvilinear system. This is the expression. Just now we derived del is equal to this. Now let us substitute all the parameters related to rectangular coordinate system. For rectangular coordinate system, h1, h2, h3 are 1. U, V, W are X, Y, Z. E1, E2, E3 are I, J, K. Let us substitute all of them here. You end up like this. Del is equal to dou by dou X I cap plus dou by dou Y J cap plus dou by dou Z K cap. This is what we used even in the entire previous unit. We were using this, right? This is how we got it from the general system. For a rectangular coordinate system, we get these values by substituting appropriate values of the metric parameters, unit vectors, and the functions. We get the expression for gradient. Similarly, you find a divergence. This is the expression, general expression for divergence. Just few minutes back we derived this. You know the metric parameters for this rectangular coordinate system. When you substitute the rectangular substitute for rectangular parameters, you get 1 by 1, 1, 1. So 1 dou by dou x of h2 into h3 is 1. So it is dou by dou x of f1, dou by dou y of f2 plus dou by dou z of f3. That's what you are going to get. So del dot f is this dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. This is what we used in our previous unit. This is how we got del dot f. Let's do it for curl. This is general expression for curl. Sorry. You try substituting the appropriate parameters, metric parameters, and the vectors and the functions here. You will get curl. I, J, K, dou by dou x, dou by dou y, dou by z. H1, H2, H3 are 1. So you will get F1, F2, F3 only. Determinant of I, J, K, dou by dou x, dou by dou y, dou by dou z, F1, F2, F3. This is our expression for curl in the rectangular coordinate system. So as per our syllabus, we find expressions for all these vector operators for curvilinear system. Similarly, we arrive at the expressions for the same for special coordinate systems also. We have done it for rectilinear coordinate system now, and the next one is cylindrical coordinate system. The second special coordinate system is, this is also another special case, cylindrical coordinate system.